All right, integration of power of trigonometric functions. So if the integral involved some higher power of trig function, in that case, we are going to use these four important formulas. There are more formulas in your textbook, but I have listed four of them here. The first one is these formulas are called reduction formula. The first one is for sine, integration of sine with nth power. N can be any integer. It is called the reduction formula because it will reduce the power of sine. You can see sine raised to nx dx is equal to negative sine raised to n minus 1x cosine x over n. So the first part is already integrated, plus n minus 1 over n times the integration of sine raised to n minus 2x dx. That means if this n was fifth power, now this will be 5 minus 2, that will be third power. So you'll see that the power will reduce when you use the reduction formula. Similarly, we have the reduction formula for cosine. Here we have the reduction formula for tangent. And this one is the reduction formula for secant. Example, evaluate the indefinite integral, part A, integration of cosine cubed x dx. So in part A, we have the integration of cosine cubed x dx. That is, we are integrating cosine cubed x with respect to x. Now, what we can do is we can break this cosine cubed x as cosine squared x and cosine x dx, because cosine squared x times cosine x is cosine cubed x. Now, if we look at this one, cosine squared x, we can recall the Pythagorean identity, which says sine squared x plus cosine squared x is equal to 1. So if I want to find, or if I want to solve this for cosine squared x, that is equal to 1 minus sine squared x. 1 minus sine squared x. So what I'm going to do is I'm going to replace this cosine squared x by 1 minus sine squared x. That is equal to integration of cosine squared x is 1 minus sine squared x times cosine x dx. So here we have 1 minus sine squared x cosine x dx. Now, if you look at this integral carefully, you'll see that inside the parenthesis, there is sine x. In fact, there is sine squared x, but you can think of that as sine x. The reason is the derivative of sine x will be cosine x. That means we can use u substitution to evaluate this integral. So what we'll do is we'll consider u as sine x. Let u equal to sine x. Let u equal to sine x. That means du will be equal to, if you find the derivative, it will be cosine x dx. Derivative will be du over dx. When I move that dx to the other side, it will be cosine x dx. Derivative of sine x is cosine x. Now we are going to make this substitution over here. Let's see what we get by substituting that. That will be integration of 1 minus, here we have sine squared. Sine x is u, so sine squared x will be u squared times, here we have cosine x dx. Cosine x dx is du. So we can write that as du. That is equal to, now you can see that this integral is easy to evaluate. Integration of 1 with respect to u is u, then minus integration of u squared is u cubed over 3, because we increase the power by 1 and divide by that new power. We use the power rule for integration. And this is indefinite integral, so we add the constant of integration plus c. Then that is equal to, because our question is in terms of trig function, our final answer must be in terms of trig function. So we are going to resubstitute the value of u. We know u is equal to sine x. So in place of u, we can write sine x, then minus, second one is 1/3, 3 in the denominator, that's 1/3 u cubed. That is, we are cubing sine function, which will be sine cubed u. Sine cubed u. And then we have the constant sine cubed, not u, sine cubed x. Sorry about that. Plus the constant of integration c. So this is how you can evaluate cosine cubed x. So we use u substitution and we evaluated cosine cubed x. Example, evaluate the indefinite integral, part B, integration of sine raised to 4x dx. Now we have the indefinite integral of sine raised to 4x, and we are integrating this with respect to x. When we have the odd degree like this one, odd power, we use the u substitution. But when you have the even power like this one, we'll try to use the reduction formula. So what I mean by that is we are going to rewrite sine raised to 4x as sine squared x quantity squared. Sine squared squared, that is sine raised to 4x. Now, for sine squared x, I'm going to use that half angle formula. We know that sine squared x is 1 minus cosine 2x over 2. That is the half angle formula for sine squared x. Sine squared x is 1 minus cosine 2x over 2, and we are squaring it. The reason is that we want to get rid of this large power. And you can see here is a square. Now inside the parenthesis, there are no more power. So always we try to reduce the power and we can integrate easily. Now, in next step, what we can do is here is 2 in the denominator with a square, and 2 squared is 4. 4 in the denominator, you can pull it out. That's a constant. So we can take it out and write as 1/4. And then we are left with 1 minus cosine 2x squared. That is 1 minus cosine 2x times 1 minus cosine 2x. So 1 minus cosine 2x times 1 minus cosine 2x, if you FOIL that, it will be 1 minus 2 cosine 2x plus cosine squared 2x. We are integrating with respect to x, so that dx will follow along. Our goal is to reduce this fourth power. You can see that over here inside the parenthesis, there is no more power, but there is a square. So when you try to FOIL that, 1 minus cosine 2x times 1 minus cosine 2x, we get 1 minus 2 cosine 2x plus cosine squared 2x. So here is the power again. We want to get rid of this power also by using the half angle formula for cosine. So that will be 1/4 integration of 1 minus 2 cosine 2x, then plus cosine squared x. If you remember the half angle formula for cosine squared x, here we use the half angle formula for sine squared x. Sine squared x is 1 minus cosine 2x over 2. Similarly, half angle formula for cosine squared x will be 1 plus cosine 2x over 2. So if there is x, you can see if there is x, it will be 2x. But here we have 2x, so in the formula, it will be 4x. So when you try to use this formula over here, it will be 1 plus cosine 4x divided by 2. We are integrating with respect to x. Okay, this will be equal to integration of Now we need to look at this carefully. We have 1/4 outside, so I'm going to write that 1/4. 1/4 outside. Here is 1, and over here we have 1/2. Here is 1, and then plus 1/2. 1 plus 1/2 is 3/2. 3/2. Then minus, this one is minus 2 cosine 2x, 2 cosine 2x. And over here you have cosine 4x/2. That means that is half cosine 4x. We are integrating with respect to x. Now, when you look at this line, we don't have any power. We started with the 4th power. Now we don't have any power. So up to here, we were just simplifying sine raised to 4x to reduce all the power. Now we don't have any power. After we get rid of all the powers, now we can start integrating. So this is equal to 1/4 multiplied to integration of 3/2 with respect to x. That is integration of constant is constant multiplied with x. So that will be 3/2x. Then minus, here is a 2. That's a constant we can write as it is. And then here we have cosine 2x. Now we need to integrate cosine 2x. Integration of cosine 2x is sine 2x. And in integration, what we do is we divide by the derivative of this inside function. There is a 2x. Derivative of 2x is 2. So we divide by that 2. So we get 2 because derivative of sine x is cosine x. So the integration of cosine will be sine. So integration of cosine 2x is sine 2x/2. Then we have plus half. Now integration of cosine 4x. Integration of cosine 4x is sine 4x divided by the derivative of 4x, which is 4. And then, because this is the indefinite integral, we need the constant of integration plus c. One more step to go. We are going to simplify this now, which is equal to 1/4 of 3/2 is 3/8. 3/8x. In the second term here, there is 2 in the numerator, 2 in the denominator. Those two get cancelled. And you are multiplying by 1/4 from outside. So it will be 1/4 minus 1/4 sine 2x. Then plus, in the denominator over here, you have 8. And from here, you are multiplying by 1/4. So 1 times 1, 1 in the numerator, 4 times 2, 8. 8 times 4 is 32. So it becomes 1/32 sine 4x plus c. So this is the value of the integral given here in part B. Example, evaluate the indefinite integral, integration of cosine raised to 4x times cosine squared x dx. So this is the product of two cosine, integration of cosine raised to 4x times cosine squared x dx. Because this is the product of cosine, you have the same base, so we can just add the powers. So this will be equal to integration of cosine raised to 6x dx. Cosine raised to 4 times cosine squared x is cosine raised to 6x. Now, because this is the higher power, 6th power, we can use the reduction formula. So what we do is this is equal to, if we try to use the reduction formula, you can see that in place of n, we have 6. So this will be cosine n minus 1. 6 minus 1 will be 5. So cosine 5x times sine x divided by n. N is 6 plus n minus 1. So 6 minus 1 is 5 over n, that is 6. 5/6 integration of cosine. Now we have n minus 2. N is 6. 6 minus 2 will be 4 x dx. So we reduce the power in first step. You can see we have the integral involving sixth power. Now we have the integral involving fourth power. Now, here we have the fourth power. We are going to use the reduction formula one more time so that the power will be reduced. Let's see what I'm trying to say. Cosine to the 5x sine x over 6 plus 5 over 6. Now here, when we try to use the reduction formula, you can see our n is 4. So if we use the reduction formula, 4 minus 1 will be 3. So cosine cubed x sine x over 4. Then plus, we have n minus 1. 4 minus 1 is 3. Divided by n, which is 4. And then integration of cosine n minus 2. When we do n minus 2, n is 4. 4 minus 2 is 2. So it will be cosine squared x dx. Let me simplify this one more step. Cosine to the 5x sine x over 6. If we distribute that 5/6, it will be 5 over 6 times 4, 24. Then you have cosine cubed x sine x, then plus. You are multiplying 5/6 and 3/4. You are multiplying 5/6 and 3/4 because we are distributing this. So 5/6 times 3/4. You can see that 3 goes into 6 2 times. So you can simplify that. And it becomes 5 over 2 times 4, 8. So that becomes 5/8 of the integration of cosine squared x dx. So we use the reduction formula 2 times. Then we change the sixth power to second power. So now we have the second power. I'm going to use the reduction formula one more time with n equal to 2. So if I do that, let's see what I get. So in next step, we have cosine to the 5x sine x over 6 plus 5 over 24 cosine cubed x sine x plus 5 over 8. I'm using the reduction formula with n equal to 2. So 2 minus 1, if I use this reduction formula, 2 minus 1 is 1. So cosine raised to 1x or cosine x. So it becomes cosine x sine x over 2. Cosine x sine x over 2. Then plus n minus 1. We have 2. So 2 minus 1 is 1. N is 2. Then integration of cosine raised to n minus 2. Now n is 2, so 2 minus 2 will be 0, cosine to the 0. Cosine to the 0 is 1, so it will be 1 dx. If you use the power rule or indices, okay, when the index is 0 or power is 0, the value of the cosine will be 1. Now the final step. We'll get our answer now. So we get cosine to the 5x sine x over 6 plus 5 over 24 cosine cubed x sine x plus, here we are going to distribute this 5/8. 5/8 and 2 in the denominator will be 5 over 16. 5 over 16 cosine x sine x, then plus, if I distribute that 5/8, 5 times 1 is 5, 8 times 2 is 16. So that becomes 5 over 16. Integration of 1 with respect to x is 1x. So that's just x, because 5 over 16 times 1x is 5 over 16x. Now we are done with the integration and we are evaluating the indefinite integral. So at the end, we need the constant of integration plus c. So this is the result of the integral given here. Example, evaluate the definite integral 0 up to pi over 4 of tangent raised to 4x dx. So here, our integral is the integration from 0 up to pi over 4 of tangent raised to 4x dx. I'm going to use the reduction formula for tangent with n equal to 4. So if we do that, this will be equal to, we reduce the power of tangent by 1, so it will be tangent cube x over n minus 1, 4 minus 1, that will be 3. It will be tangent cube x over 3. Then we have minus, and then integration of, we reduce the power by 2, so when you reduce the power by 2, it will be tangent square x dx. Now let's take care of this limit of integration. This is from 0 up to pi over 4. 0 up to pi over 4. This is already integrated, so we have to evaluate this from 0 up to pi over 4 using the fundamental theorem of calculus. So let's evaluate the first part. In order to evaluate the first part, we plug in the upper limit, we subtract and plug in lower limit. So if I plug in upper limit, it will be tangent pi over 4 cubed. Tangent pi over 4 is 1, 1 cubed is 1, divided by 3. Then we subtract and plug in lower limit. If you plug in 0, this will be tangent 0, which is 0. 0 cubed is 0, divided by 3, that is also 0. Then minus, now we need to integrate tangent squared x. So in order to integrate this tangent squared x, I'm again using the reduction formula. Reduction formula says tangent n minus 1. When I reduce the power by 1, this will be tangent x. And then divide by, you can see n minus 1, we are dividing by the same power. So here is power 1. When you divide by 1, it will just remain tangent x. Then minus integration of tangent n minus 2, you are reducing the power by 2. So 2 minus 2 will be 0. And tangent raised to power 0, it will be 1 dx. Now we need the proper limit of integration. It is from 0 up to pi over 4. 0 up to pi over 4. This one is integrated, so we have to evaluate from 0 up to pi over 4, which is equal to, here we have 1/3 minus 0, which is 1/3, then minus, for this one, we plug in the upper limit. When you plug in upper limit, it will be tangent pi over 4, which is 1, then minus, you plug in lower limit, it will be tangent 0, which is 0, then minus, here we have integration of 1 with respect to x, which is x, and we have to evaluate this from 0 up to pi over 4. Now let's see what we get. This is equal to, we have 1/3, and then here we have minus, if I'm subtracting this, it will be minus 1. I'm subtracting a 0, so I don't have to worry about that, but negative and negative, that becomes positive x. This x must be evaluated from 0 up to pi over 4. Now here we have 1/3 minus 1. 1/3 minus 1 is negative 2/3. Then plus, here we plug in the upper limit in order to evaluate this. If you plug in upper limit for x, that will be pi over 4. Minus, if you plug in lower limit for x, that is 0. So we get our final result, which is 2/3 plus pi over 4. You can write 2/3 plus pi over 4, or you can write pi over 4 minus 2/3. So that is the value of the integral given here in part, no, given here in this problem. Example, evaluate the definite integral 0 through pi over 4 of tangent squared x times secant x dx. Now, in order to evaluate this integral, I'm going to use the reduction formula for secant. So if you want to recall that formula, it is secant raised to n x dx, the nth power of secant. When you integrate, it will be secant raised to n minus 2 x, change in x, divided by n minus 1, then plus n minus 2 over n minus 1, and then integration of secant raised to n minus 2 x dx. So you can see that the power reduced by 2. Okay, here we have the definite integral 0 through pi over 4 tangent squared x times secant x dx. Now from the Pythagorean identity, what we know is 1 plus tangent squared x is secant squared x. So that means tangent squared x will be, if you subtract 1 on both sides, it will be secant squared x minus 1. Tangent squared x will be secant squared x minus 1. So that is what I'm going to plug in here for tangent squared x. So we can write that as 0 through pi over 4 secant squared x minus 1 times secant x dx, which will be equal to 0 through pi over 4. If I distribute this secant x times secant squared x will be secant cubed x, then minus secant x multiplied to 1 is secant x dx. Now I can split this to two different integrals. The first one will be 0 through pi over 4 secant cube x dx, minus the second integral is 0 through pi over 4 of this one, which is secant x dx. So this is equal to, I'm going to use the reduction formula for secant cube. That means n equal to 3. And if I use that formula, it will be secant raised to n minus 2. 3 minus 2 is 1. Secant raised to 1x, or secant x times tangent x divided by n minus 1. N is 3. 3 minus 1 will be 2. Then plus n minus 2. 3 minus 2 is 1 over 3 minus 1 is 2. And we are integrating secant raised to n minus 2. 3 minus 2 is 1. So it will be secant x dx. So that is for this first one. Then we have minus integration from 0 through pi over 4 secant x dx. Let's write the proper limits of integration. Here it is also the integration from 0 up to pi over 4. And the first one is already integrated. So we just have to evaluate this from 0 up to pi over 4 using the fundamental theorem of calculus. That will be equal to, in this one, if we plug in pi over 4, let's see what we get. If you plug in pi over 4, this will be secant pi over 4. What you know is cosine pi over 4 is square root of 2 over 2 from your unit circle. Cosine pi over 4 is square root of 2 over 2, which is same as 1 over square root of 2 from unit circle. Here I'm looking for secant pi over 4. Secant is the reciprocal of cosine, so reciprocal of 1 over square root of 2. So that will be square root of 2. Multiply 2, tangent pi over 4 is 1. Then we have divided by 2. Then minus, now we need to plug in 0. You know that cosine 0 is 1, so secant 0 will also be 1. Multiply 2, tangent 0 is 0 divided by 2. So when you evaluate the first one, when you plug in upper limit, we get square root of 2 times 1 over 2. And when you plug in 0, you get 1 times 0 over 2. Then, if you look at these two integrals, they are the integration of secant x. Both are integration of secant x. Both are integration of secant x. One is half, one is minus 1. So half minus 1 is negative half. So we can write that as minus half 0 up to pi over 4 secant x dx. So you have half of them here, and here you have negative 1. So half minus 1 is negative half 0 through pi over 4 secant x dx. This is equal to, this one is 0. 1 times 0 over 2, that is 0. The first one will be square root of 2 over 2. Square root of 2 over 2 minus half is constant as it is. Now integration of secant x. If you remember from your calculus 1, integration of secant x is the natural log of secant x plus tangent x. Natural log of secant x plus tangent x. That is the integration of secant x. And we need to evaluate this from 0 up to pi over 4. 0 up to pi over 4. So that will be equal to square root of 2 over 2 minus. Now if we plug in the upper limit, let's see what we get. If you plug in upper limit, it will be minus then half natural log of, if you plug in pi over 4, it will be secant pi over 4. Secant pi over 4 is square root of 2. And then if you plug in pi over 4, tangent pi over 4 is 1. Now you are subtracting minus, and you are subtracting a negative, that means plus half natural log of, if you plug in 0, secant 0 is 1 plus tangent 0 is 0. Now let's go to the final step here. The first one is square root of 2 over 2, then minus half natural log of absolute value of square root of 2 plus 1. You don't need the absolute value because this is always positive. So you can write as half natural log of square root of 2 plus 1. This one here, 0 plus 1 is 1. Natural log of 1 is 0. 0 times half is 0. So that means this is my answer. I can write it as, because there's a common denominator of 2, this can be written as square root of 2 minus natural log of square root of 2 plus 1, all divided by 2. So that is the value of this integral, which is given here.